Hello and welcome to another Pixel Mosaic Tech Chat. You might be curious why Playback and media server operators insist on specific formats for video elements. Today we're going to take a look under the hood at what is at the very core of a video file, codecs. Simply put, a codec is a piece of software that compresses and decompresses data for faster transmission. Think of a codec like a decoder ring you would get in the box of cereal to solve a word puzzle. In this example, our codec works as a series of instructions to both generate and solve the puzzle. The encoder generates the puzzle, and the decoder solves it. All codecs have different instructions based on their intended usage. Uncompressed video is raw, unaltered video data that does not require any decoding. So you might ask, why bother with complicated encoding and decoding algorithms in the first place? Why not just use uncompressed video for everything? Well, imagine someone is asked to read all of Moby Dick for a crowd.
Call me Ishmael.
They must read at a very precise and consistent pace to accommodate the needs of the audience. Using uncompressed video during an event would be like reading from a massive, heavy book, word for word, while needing to flip the page every few seconds. The reader becomes overwhelmed, which leads to mistakes in their performance.
Lotion with me. There now in your...
This would be the equivalent of dropped frames and other errors in the playback of video media. On the opposite side of the scale, there are codecs like the low bitrate H.264, which rely heavily on encoding and decoding information. These formats are designed to solve various challenges, and a key aspect of that solution is they can maintain a very small file size. But in the playback world, that can lead to some very risky business. Let's return to our reader now with a book encoded in one of these formats. The book is much lighter, but it has full sentences, even full pages missing. In order to fill in the gaps, the reader must commit a large portion of the story to memory, using only the key sections that remain to help fill in the rest.
The sea had jeeringly kept his...
Because the reader has to read at a constant pace, they are put on the spot and are subject to a high level of error. The result are issues of varying degrees, from dropped frames to weird-looking blocks of incorrect color information. In our world of real-time video playback, these formats can cause some serious havoc in our performances.
Pip saw that it was the multitudinous...
When your media server operator requests files in formats like ProRes, HAP, or Notch, it's because those formats provide the best balance between the volume of data, flexibility, and a more efficient decoding formula. Codecs like HAP and Notch were engineered specifically with large frame sizes in mind, making them ideal for playback on large LED walls and in immersive screen designs. A codec like H.264 is designed more for traditional broadcast frame sizes typically found on web and streaming platforms. It would be as if the book were only missing the vowels or a few words here and there. Not as heavy as the full source material, but it still retains all of the information required to accurately convey every detail. This sets our reader up for their best chance of success, just like we do for every event that we operate. Additionally, some codecs can get extra assistance from their respective hardware resources that can provide even more accurate decoding. It would be as if our reader was given a constant jolt of caffeine to help with focus and maintain energy.
To the last I grapple with thee, from hell's heart I stab at thee.
Our metaphor is, of course, not exactly an apples-to-apples comparison with how video codecs work, but it should give you a better understanding and appreciation for what's taking place under the hood during critical playback moments of your event. If you've ever questioned why your playback or media server operator has insisted on avoiding a seemingly convenient format like H.264, hopefully this video has helped provide you some answers. Thank you for watching. Follow us for more videos like this, and to see the other work we're up to, head on over to pixelmosaic.com.